Well, that's a mighty big beast right there. That's an 8-ton air handler. And as you could see, it's in a very narrow, low ceiling wall. Um, it's in my office, and this is an LG 8-ton system. So this is a unit that I'm going to be using for testing and setup of different duct designs, different filter designs, testing the static pressure and airflow, and designing special application ducts where they're very slow. And I'm going to design a ducting system that basically uses like anywhere from a 4-foot to 6-foot, just a slow, small throw, and use the, if I could pronounce this right, the Collinging effect. The effect where if you blow air along the ceiling, the air will actually go farther than if you have a duct. If you have a duct sitting several feet down in the air and you have it coming out and shooting, it'll only go so far. Let's use an example, say 22 feet. But if you take that same duct and you run the ductwork up to the ceiling and you shoot the air up towards the ceiling, it'll be like water traveling on the floor, and instead of going 22 feet, maybe it'll go 35 feet. And so I'm developing different ducting to take advantage of this situation. But this particular air handler has some advantages because this exact same chassis could be a 3-ton, a 4-ton, a 6-ton, or an 8-ton unit, all in the same chassis. So I use this chassis over and over again in many different applications. But when you have these different output, you have different output of air. So you have to actually design the duct and design it for a minimum static pressure. So if I'm designing ductwork for a 3-ton unit, I have to choke it down and narrow it down so it has a minimum of a 0.2 static is what this air handler calls. This is a high static pressure air handler, and I have to design this ductwork for a 0.2 static for 3 tons, which will be a lot smaller than a 0.2 static for 8 tons because you'll be flowing a lot more air. So you actually have to do the math and figure out what it is and then measure to prove. That's about it. This will be an upcoming project for testing. Different filters for the back here. So as we come around the back, you see here's the coil right here. That's the evaporator. It's a lot bigger than a Honda evaporator. And off the back of this, I'm designing a couple different kind of air filter housings that'll be coming off the back. Some of them will shoot straight back, some of them come down at an angle, some of them come straight down. Some of them involve large carbon canisters filled with carbon, active carbon, and each canister could weigh up to like 160 pounds a piece, and they have a certain airflow that they can flow through them for eliminating odors. And also Merv 13 filters, Merv 16 filters, and true HEPA filters. I'm trying to work on a design for this particular unit where I could put big enough HEPA filters on it that it doesn't have a large static drop. So I could use something that's acceptable, and it's going to have to be a real big HEPA filter, multiple of HEPA filters with pre-filters in front of it to flow this much air. But that's my end game goal, is for me to do the sheet metal and design the combination of filters for the inlet and some duct work that takes advantage of very unique filtering situation that's needed in some pharmaceuticals, where you're in manufacturing of certain pharmaceuticals and you have to have HEPA clean air, and that's something I'm going to be designing on this. All right, that's all.